Hi, I'm preparing this video with the intention of assisting in the process of installing virtual environments in order to run the package bvspm that we created as part of the iWare terrains project. The main focus for this very quick tutorial is to guide you through the different steps that you will need to follow and how to actually clone the repository and run the program. So here we have a detailed explanation. If you have seen GitHub repositories, you may already be familiar with this. However, I think it may be useful just in case to go through the different steps. So we will start by cloning our repository, something that I'm gonna do right now by simply clicking on this repository. Notice that this is the same hyperlink that we have up here. Then I'm gonna go somewhere in my computer. I have it here already, but I'm gonna create a new clone, and this one is gonna be called legacy, which is really not is the main repository, but oops, it doesn't let me. I'm gonna put it somewhere else. Let's put it right here. So here I am gonna access the terminal. I'm gonna type because I'm using Windows CMD here in the browser that appears at the top, and by clicking enter I'll be able to open this folder in my terminal. Then because I have Git installed, Git for Windows, if you're a Mac user or Linux user, you probably already have this by default in the part of the back end of the machine. Most of us already have Git installed. If you don't, you can search on the internet on how to install it. Then I'm gonna type git clone, and then I can right click. So if everything goes well, the information that was submitted to our GitHub is gonna be downloaded because this is a public repository. So once we have it, we can enter that folder and we can locate the environment and the setup. This one, YAML, works for those of you that may have Anaconda as an environment controller or environment manager. And today, however, I'm going to show you how to use the setup.py. We're going to create a virtual environment, also known as VMB. Let's go back to the terminal. So here, we are still one level up. And the reason why I do this is because I need to create a new subfolder that is not going to be part of the bvspm package. We first need to access a version of Python that is equal or higher than 3.9. In my case, I am a fan of Anaconda environments, so I already have my environment, which I called for other project like Pixel M. And oh, it seems, do I have Conda? Yes, I do. So Conda activate pygame dash sorry, force of habit like pixel dash m. I think that should work. Yeah, there we go. Okay, and the reason why I have this specific environment is because of its version. Notice that in this particular capsule that contains a standalone installation of the Python interpreter, I have a version 3.12. As I mentioned, we need 3.9 or higher. Now that I am here, I can type Python, which is gonna run the version 3.12, then -m vmb, and I'm gonna name this the name of I want my environment to have. In my case, it's gonna be called spm-m, and I'm gonna press enter. Then we need to be a little patient, and after perhaps 1 or 2 minutes, the virtual environment should be created. Now, if we go to the folder, we can see that there is something happening there already. There is 3 main folders that appear in a Windows machine. In a Linux or Mac OS system, these should also include a bin or binaries folder. And those binaries are the ones that contain the scripts that at the end of the day you're going to need to access, which is called the activate. So if I enter scripts, you will notice that I get instead what is known as an bat file. The bat is the Windows version of running a script, what in Linux is bash, and also in Mac OS. So if we go back here, we can activate our environment. we go down here, we can see that that is exactly the steps that we just followed. And I'm going to copy this one right here. Back in the terminal, I can right click. However, my environment is not called bvspm, it's just called spm-env. Notice that inside of that environment, I access the script subfolder, which is this one, and then the activate, I think it's called .bat, is located in there. Notice that I just put the .bat in there. And here on the left, we can see that now we have in brackets the name of that environment. So pip, the installation package that Python has by default, you can type pip install, and then you can install all sorts of packages like pygame. Things that are not installed by default with the native or vanilla flavor of Python, but are rather, you know, like installed from a catalog that is made available online and is the official repository from Python. However, we can also install things locally, things that other developers in our groups may have created, and that is exactly what we're about to do. So among other things, we can do pip list to reveal the libraries that our environment has already installed. Now, apologies for this window. That blue window is my antivirus that sometimes erases things from my computer, and I think it just did. So if I do python -- version, okay, it's still there, at least that works. Good. Okay, so let's install our library. We are gonna access the insides of this folder, and to do that I type cd for change directory, iware terrains. In here you will notice I have the setup.py file. I will type pip install -e dot. Now -e is called the edit mode, and that means that rather than installing these packages globally wherever, you know, most packages are installed in Python, which is in a very cryptic and hard to find folder, it's gonna install it with reference to the folder that is a repository. And that is important because if you decide to make changes to the folder, those changes should be automatically applied. Now, we just need to wait until the package is finished installing. Some of the important libraries that are being installed include, and this is kind of like the most important ones, Pillow, which allows us to handle images in the form of data arrays, using NumPy, I believe. Yes, here it is, NumPy. We also have scikit image and matplotlib, which should be installed somewhere in there. Yeah, that's the next one. So, and finally, notice we are installing also our package, right? So that's what is inside of that setup. I'll give it a minute, and through the magic of video editing, I'll be back in just a second. Now let's try pip list once more. And if we press enter, this time we will see, hopefully, that we have many libraries installed. Among those, look at that. We have the location where our package bvspm was originally installed. So now it's time to use it. Let's type dir and let's enter the file called example usage, which I should probably call example use, but that's okay. So I'm gonna type in here code dot, something that may work on your case if you have VS Code installed. Regardless of what IDE editor or code editor you are using, you should be able to open a file, a Python file. That's what we're doing right now. Okay, so what is happening here? So here we are importing two main libraries. The first one is NumPy, which we will use to print some quick stats on the image that we read as an output of our program. And the second one is the start of this show, which is bvspm. Now from here, we're importing three libraries: process and visualize. This is the one that does the heavy lifting. reading and handling the headlines of that weird format SPM. Then we have a utility to save raw images as TIFF, and finally a small utility that allows us to calculate the SA, which was the intention of the original implementation of this program. Now let's specify a path file. Now first, let's find our root. Let's find an example of an image. I'm gonna open my folder once more. I may need to navigate somewhere else. Actually, let's use the example, because I believe inside of images I left an example for this project. Yes, there it is, test.spm. So let's use that. So there are multiple ways to do this. We can use a full path or a relative path. A full path is the one that specifies every single folder that we navigate in order to end up in this image. So it looks like this in my particular case. Also, we need to type R here. That means raw string. It means that we'll be able to read things literally, because notice there is a /t that is a special character in regular expression and it creates problems when reading files because it means tabulation. So like this, there are many other cases, but you know, backslashes and forward slashes are also part of the normal way that we communicate the folder structure. So that's why we need to make the distinction. So in here, we have the test.spm, and the other way to do it is by using relative paths, which actually VS Code does very nicely. So I type double quotes because this is a string. I type dot to say I am in this current folder, /, and then I can select images. Inside of images, I type /, and then I can access test.spm. And notice these two are the same thing. Let's use the first one, just because it was there first. And the next part, which I'm not going to change, is the part that processes, opens, and retrieves the high map for this particular file. Let's run the code. And to do it in VS Code, I can simply click in here and then run it as long, and this is very important, as long as I am in the correct environment, spm-m. So that is one way to do it. The other way to do that is going back here. I believe that's where example usage was. Yes. And then I can say Python run example usage for me. And I press enter. Let's see what that does. Now, if everything was installed correctly, we should see a very quick summary of the different stats on this document, along with an image made in matplotlib that contains a roughness map of our SPM file. Along with it, if you notice in the script, we also have one call to a helper function called save raw TIFF, and this one receives the high map and a path file. So wherever images is, we now also have additional information. Let's find it. Here it is. Next to the original file test.spm, now we also have the test metadata JSON, which gives you the information on the most important parameters that we may want to retrieve from the SPM file. The other file is a raw TIFF representation of this image. Notice that there is no bar here on the right. It's possible also to export the image directly, so that's why I didn't add it, but it can be added. I think it is possible to install it. That's what I thought. We also have a helper function that does that. I don't know if it did it here. Yes, it did. Look, here it is. SPM high map. At least I think it exported it. And if you open this one, that one is not a TIFF file. That one is just a regular image, and that one contains some of the metadata embedded in that image. Okay, hopefully this is useful. Please let me know if you have any questions or you have any ideas on how to improve on this program. And I hope it helps with the process of making pipelines for these kind of applications.